learned a new rule for finding the derivative. So taking the derivative of a natural log. And as we learned in chapter 4, integration is really just the reversal of those derivative rules. So 5.2, we're kind of following up how to take the derivative of a natural log with how to reverse that rule. And so we're taking a look at integrands that follow this pattern here where we have 1 over x dx. And when we see that pattern, we can integrate that. The antiderivative of 1 over x is natural log of the absolute value of x plus c. And then we can also do the exact same thing, the same pattern with u, so some function of x. If we have 1 over u du or du over u, we get the antiderivative is the natural log of the absolute value of u. So we're adding on some complication in terms of integration, and we're starting to see that even though no one particular type of integration is all that difficult, it can become difficult to recognize which pattern we should try to apply. And so that's really the key to integration, and it's really what makes integration a more difficult problem than derivatives, and that is just trying to recognize the pattern and rewrite the integrand in an appropriate pattern so that we can integrate it and use the techniques that we know. So the guidelines for integration is know the basic rules, use u substitution to make the integrand look like the rule that you know, and if that doesn't work, then we try to rewrite the integrand and then try to find a u substitution that will work. All right, so let's look through some examples here. We're going to start off with some fairly simple examples. The first example is the integral of 5 over x dx. And so just to simplify that integrand a little bit, I'm going to pull that 5 out, and now I just have the very basic rule for integrating. I have 1 over x dx, and I get the coefficient of 5 and the natural log of the absolute value of x plus c. And I could leave it like that, or I can bring the 5 in here as the exponent of the x and write it as x to the 5th. So the next problem we have is slightly more complicated, but you can see that I guess what we're looking for here really is the numerator is the derivative of the denominator, and that is a kind of a dead giveaway for a du over u type of problem. So if we let u equal the denominator, then we know the du is just the dx, and so we have everything here that we need, and we can rewrite it as 1 over u du. And then when we do that, we get natural log of the absolute value of x minus 5. So the next example is a little more complicated. So we're going to do a definite integral this time, so we're adding a little bit of a level of complication there. We have 3 minus x cubed over x squared dx. So let's look at the u substitution that I chose to use here. I'm going to let the denominator, I notice that if I take the derivative of the denominator, I at least get to the right power of x here. So the derivative of an x cubed is going to give me an x squared. So that's a good hopeful sign. So I let u equal 3 minus x cubed. The du is negative 3x squared dx. What I'm trying to substitute for is the x squared dx. So I take my du and I solve it for x squared dx, and I can see that the x squared dx is going to be replaced by a negative 1/3 du. So there's where the negative 1/3 du came from. And then this denominator is just u, so I have my du over u. All right, so as I have changed this integrand to be in terms of u, I also need to change the lower and upper limits there. So I plug those into my expression for u. So I have my lower limit is 0, so I do 3 minus 0 cubed is just 3. And then I do the upper limit is 1. So 3 minus 1 cubed is 3 minus 1 is 2. So now my lower limit is 3 and my upper limit is 2. So when I do this integration, I have my negative 1/3 times natural log of the absolute value of u evaluated from 2 to 3. Alright, so that is negative 1/3 times ln of 2 minus ln of 3. Notice here that I don't really need the absolute value symbol anymore because I'm just using 2 and 3. Those are both positive values. And I can rewrite this as the natural log of 2/3. And then I could leave it like this, or I could move this negative 1/3 to be the exponent of 2/3. So just so we can see it, it would be there. We wouldn't want to leave it as a negative 1/3, but we could make that natural log of 3/2 to the 1/3, which we could also write as natural log of the cube root of 2/3. Sorry, of 3/2. We change it to 3/2. So it should be the cube root of 3/2. So any of these really is well, this one really isn't because it has a negative exponent, but this one's okay, and this one's probably as simplified as you can get it. Just be aware that you might see an answer in an answer key somewhere or something like that in any of those forms, and you should kind of be able to think through sort of where they came from.